Okay, 10:10. We are starting. Unfortunately, I forget to record the the last hour, so I will just try in 10 minutes remind you what we have been doing, and by this we will have it in our recording. Now it's started to be recorded, so everything is fine. I will just quickly go and explain in 5 minutes what we have been doing it since last hour. So first of all, series, it's producing a list. So if I go for the panel, I will have a list of numbers. Those lists, you can generally find the length of it and also some specific items. The easiest way to find the item, specific item, is the list item. You can make it like this, just connecting the list, and then you will have a single output of it. So the only thing which you need is the index. You can place here a number. I will start from -1 to 9. And thanks to using -1, I can find the last element in the list. So this is a trick, which is not so obvious. When it's come to the 0, this is the 0, so it's 1. To make it maybe more random, to not to distinguish from the start, step, and count, you see I implement 2.3 as a start. Now I have different numbers, so I know the 0 here, it's this 0, 2.3, it's this 2.3. Okay, so this is how to find it. The trick is to place the -1 if you're looking for the last one. You can always read the list length. And it will give you 10. 10 because it's indexing from 0. So if you have 9 and ninth element as the last one, it means that probably if you were indexing at least from 0, you didn't cool anything before, then it's this is 10th. If you would like to find the last or sorry, if you would like to find where are the operating all the components which are responsible for dealing with the list, hold left control, left alt, and left mouse button, and it will give you the tip where to look for those ones. So it moved me to the sets, and then I have list, and here I have all these things which I can use with the lists. So list item, list length, item index, replace items, and so on, and others like this. We will go into sequence now to see the again the cool pattern, cool index, and stuff like that. So those operations are deleting specific elements from the list. I will go for the cool index, which is the basic one. I will take this series and make the my own list. So right click, it's making multi-line data, and now I can make my own list. In this instance, we'll make my let's make it on the half of the screen. It will produce a list which is taking every second element. So he delete the index of 0, 2, 4, and 8. It doesn't have, I can also delete just 2 of them or just 1 of them. If I would like to cool some pattern, it's very useful to use cool patterns, because then I can create a panel and make my own pattern list. So now you see it is not a list, this panel, but if I right click on it and set to multi-line data, this is a list. So this will make a cool pattern for my list. The last one, it was cool env item. So here I can make 2, 3, 4. And now it is deleting every third, for example. So 2.3 he's leaving, 3.3 he's leaving. This one he's deleting. Yeah, it is not here, so it is working. Okay, so this is about cooling and items. Let's go into the trees. For this, I will use again series, and I will just create the code for the building from yesterday. So step should be something from 4.5 to 10 meters. Count should be something from 3 to 10. And I will just copy paste those two. So now I will go for the introducing a point, construct point. I will combine it to the X and to the Y. Let's take a look. Yeah, since I have only 3, he is generally creating a flattened list. So I would like to create a grid. So I am grafting one of the inputs, this one, and this is introducing branches into our code. So each time one branch is coming, this whole set is restarting for the whole list. So since I graphed y coordinate, it will make y coordinate, or I will make it like this. It's explained a little bit more if I will graft on this side. So, so in the first branch is 0, in the second 4.5 and 9. This means that in the first branch of the new outcome from the point will be zeros, 4.5, 9s, because he take this zeros or combine it with this series and make it here. So for whole this branch. So he even have the same naming of the branches. Here is 0, 0, here is 0, 0. If I will just, yeah. So for 0, 0, 1, coordinate 4.5, which is here, will be here. Okay. We have a points which are grafted. Now I will introduce project. Project you will find in the transform, affine, and here you have a project. I will take this geometry. I will introduce XY plane. I need to have the origin of this plane, so it has to be a point, construct point. And the only thing which I am missing here is that construct point is just 1, and I would like to have it at specific levels. Those specific levels I will introduce manually, so 0, 3, 6, 9, 5 floors. Z coordinates, oh, he has a red balloon. So the data conversion failed from text to number. It's not true. He has the problem that this is not a list. So right click on it, multi-line data, and suddenly we have our solution. Here, I need to make one trick. Since the plane it's a list and this is grafted tree, the bunch of points, I have to switch it. This should be the grafted and this should be a list. So this I will flatten and this I will graft, because this will make me working that I have in single branch one plane to which I want to assign all of the points which I have as a list. Unfortunately, if it would be a tree, this point construction, then it would be messed up with the addresses. So this plane, it would be hard to combine with those points. Okay, so we have our points. They are already kind of the good categorized. Let's take a look how the data structure is looking here. So in each branch, we have a set of the points, and generally the branch is responsible for the single layer. So now if I will take branch, tree branch, and I will go here, just to make it clear, I will simplify it, and I will make a slider from 0 to 4. I will make a sphere. I have the points in the specific floors. Okay, so I have them, but if I want to create a columns, I would like to rather have them not in this position, but I would like to flip this matrix, flips this data structure. I will combine it with the data matrix, and then if I will go here, I suddenly see that I have my correctly set up points. Okay, so I have those points. I will create a polyline. Those are just geometrical operations, not so important at least today. And this one I will just turn off. So I will just leave the polylines. Now I will find the endpoints of it. I will create a circle. 0.2, it's the radius start endpoint. I like to use merge to make them as a list because I can control the order of the elements in the list, and then I can just loft it. I have lofted the columns, and now I can. But I like to have it as a closed BREP because if I will go for the volume, maybe in this case, no, it doesn't because it's not a closed BREP. I cannot measure the volume, so I cannot measure the price. I cannot measure the weight of it. So I need to have it as a closed BREP. So to make it, the fast way is to make cap holes. This will make it as a closed. But alternatively, I would like to show you something which is more general. I will use boundary surface. Not for the loft, but for the results. And now it is important and join BREP. So if I will join BREPs which are making a closed volume, it should make from this set of the BREPs a closed BREP. And remember, the surface is also a BREP. It's a specific case of the BREP which doesn't have the volume, but per definition in Grasshopper, in Rhino, BREP it's a surface. So BREP is more general than the surface. You can describe surface as a BREP, but not every BREP you can describe as a surface. Okay, and now the joining. If I will join straightforward with the holding shift, let's take a look if it's closed or not. Closed, closed, closed. So it seems that they are in the same addresses of the branches. Let's take a look. Yeah, so since this flat surface, two flat surface, which are just the closing of the pipe, are in the same address as the vault of this pipe, then it is able to closed. So I can measure the volume. If I will come back to the beginning of my code, now if I will measure, create a little bit setting and make it more like it was during the first day. So I think it was 8 meters, 8 meters in the X direction. I think it was just 6 objects. and I have 5 meters here. If you want to quickly go, you can double left click on it and just type 5 on the slider, and here I got 4. So I have my code. What is nice that it's still very parametric and easy code, so it seems like everything is working here. Okay, so in those couple of minutes, 16 minutes, we explain most of the things we were doing in last hour. Maybe it was a good reminder. Now let's go for the polylines. They are here. I will take those polylines and I will type just a curve container. I will grab these polylines. So if you are using the code from the previous, you should also have it. Just find the polyline. It should be here. Okay, so we have our curves, the polylines, which are just the lines. Based on this, I would like to the next thing what I would like to have is to use the planes. So I will type plane, and since I already setted them, so those are the levels, I will just take those planes. So I have those two, and I would like to use them. So I will take this curve, which are the polylines, and curve is the most general description of every curve looking like geometry. So if it's a line, polyline, circle, or NURBS curve, you can describe it as a curve. But not every curve can be described as a line, obviously. So curve container, it's very general. But there is more general, which is called geometry or data. Data will handle every type of the geometry, the curve or the number. So if you have a number, it will also hold it. When the geometry will not hold it, curve will not hold it. But the geometry, it's obviously able to handle the curve. So we have the curve, we have the plane. And now I would like to make to find endpoint of this curve. I have the endpoints. So what I will do now, I will just flatten the list of my polylines so they are strict. I have them. So this is now the list. The start points, it's also a list, and endpoints are also the list. Just to figure it out, where is the beginning, where is the end, I will just connect sphere, and I know that the start, it's in the bottom. If I would like to shift this order, I can always, in the curve, I can flip the curve. It was called flip. So if I will flip the curve, I will have the opposite, at least I should, yeah. But it was okay. So if you have flipped, you can flip it, but also you can just connect it to endpoint if I want to have those one in the bottom. So since I found those one, I will go for the point container and call it point on the bottom level. So this is one thing. Now I will just make something which is in the mesh ribbon. I would like to have a convex hull. I will explain you in a second how it is working, but generally it finds the boundary of your collection of the points. So if you have a collection of the points, you see that generally he found the polyline, and whenever I will be changing the dimensions of my grid zone, he will find corresponding boundary of my points. So I will use that one, polyline curve, and now I would like to just take this curve. I think it's a polyline curve. Since it's a polyline curve, then I will be able to explode. If I can explode, this was also explained yesterday, I will see the segments. I have 4 line segments. If I go for the item, list item, I can create, if I zoom in, sorry, maybe I was a little bit too fast here. Here are the polylines endpoints. I found the elements which are on the bottom. I named them point at the bottom level. I found the convex hull, Control Shift, it's in the mesh and here. And then I just make a container curve for it to just be able to read it, the type, but you could also go like this. It will not make a difference. I explode it. And now I have 4 lines, but I would like to have those 4 lines, all of them. So I don't want to type 0 every time and then 1 and 2 and 3. So since there are only 4, so I will just quickly quickly zoom into list item, and here you can find small plus. I will do it 3 times, and this will be the first item, the second line, and the third and the fourth. What doesn't mean I plus 1, I plus 2, I plus 3. It's I from this index, which per default it's 0. So if I have here 0, it means that this is I 0, this is 0 plus 1, which is 1, 2, 3. So if I will change it to 1, this means that this will be the first one, this will be the second, third, and the 0 one, because this will be, it is repeating the loop over the list elements, and this one will be the first one, and this is the second one in this case. Okay, so I stay with the 0. So if you have per default 0, you don't have to change it. And now let's try to find which one is which one. I will type pipe. Pipe, it's a very useful thing, the same as sphere. It means it needs just one information. It just needs a curve. If I will have a curve, I will know where exactly my line is. So I now know that the 0 item in my segment list is this one. The second one is this one. The fourth is this one. The fourth, the third is, was the previous one, and the fourth is this one. So thanks to using pipe, I just can quickly highlight the object. Of course, you could type just a line and hold it, and you will have a green here, but pipe, especially with the big models, it's sometimes more visible. Okay, so I have this one, and I would like to offset curve. I will, or I maybe, yeah, let's use offset then. I will choose the curve, then the distance, it's 1. Let's see it from the top. I will turn off the pipe. I see he is offsetting it like this. Now I have offset curve. Also the third one. Let's see. This one, it's also offsetting here correctly. And in those two, I will type from 0 to 2. So this should have like this, and those two should have a little bit bigger distance. Okay. Now, mm, there is a way to make, as you can see, I will just turn off other previews. And I will go for the half of the screen. Okay, so it offset a line, but he loses the information about the corner. So there are many ways to find the corner, but I will show you maybe not the best one, but the one which should teach you about the again about the whole like the how to use convex hull, because I think it's important to also use this. So I will go for the endpoint, and again I will find the endpoints of my lines. Alternatively to it, since it takes a little bit time, I could just merge. I will delete those three. Connect the curves inside. So now I have a collection of all 4 points, and do like this. Maybe this will be faster. And based on this, I could try to find the minimum and maximum of our object. So we have start point, end points. I will merge it again. So I will create a point. This time I don't care about the order of it, so I will just merge it like this. So I have 8 points. Those 8 points are generally creating it's creating orthogonal info. It will give me all the information which I need to create my rectangular um, rectangular shape of the floor, because it has the information about the limits of our floor. So I have a point. I have to just deconstruct it. And now raise the hand if you have those points. Is somebody following me? So, I killed them. Yeah. So, okay. Then, if anybody didn't, okay, then I will just give you this file. But the most important thing is, if you don't have those ones, you can just take those one from the polylines which you have here, and maybe just take endpoints of and start points. So if you take the polylines which you definitely have, so you can take the start points here and work on those points. So if you have these points, it's also okay to operate on them like I will be doing right now. So you have to deconstruct them. We just have to flatten them. So maybe I will do, I will continue on my list of points, and let me check. I will just give you a print screen from my, so should be, so this is a code. Which graph was used on the curves? Which graph was used? That's here I didn't use any. If here was just flattening, previously I just flipped matrix. So let's come to the beginning. Those you probably have, all of you, I hope at least. We are constructing a grid of points. It's here. Then you have also to introduce XY planes. Yeah, but let's go slowly through the code. If you have a list of planes, then you are on the correct path to make your task. Then you are projecting it. So you should have it in the 3D. So if you are here, if you are having this one, it's also right now you just have to flip this matrix and connect it with creating a polyline. This code, I don't care right now. You can take it later, how to make a B-rep. The only thing which you need to do is to create those polyline. So it's not so difficult, I suppose. Let me make a print screen. So creating this code should be like a couple of seconds, maybe even milliseconds. Just joking, probably some minutes. But anyway, those of you, we are training it from yesterday, so getting to these polylines should be fine. Then I just find the endpoints of, I just flatten it. I have a list of polylines. I found the starting point. And here it's a little bit of mess, but to find the offset, I make a convex hull. Convex hull, it's in the mesh. Here you will find convex hull. It's from the collection of points. He's finding the obvolute, the boundary of collection of points. Those you can just combine to explode, and you should have 4 lines because for a so simple shape, it should get you a polyline. From this polyline, you should just have 4. And now here can be a small mess, but the deal is that to have 2 of them with the different slider, because it can apply then a different offset to the left and right, and from the bottom and the top. So if you have those 2, you just have to order it by yourself. Maybe in your code it's a little bit different, so you have to manually check which one are which, and then you are just merging it into the one list. When I try to delete or write in it is instead appearing in command in Rhino. Are you sure you are double clicking here in the empty space? But maybe we'll take it in the break. I just want to, we will make break soon. Or let's make a break right now. You will be able to chase me. Let's make 15 minutes of break and we are coming back at 11. So, but I am here available for your question. So back at 11, and I will make also a print screen out of this one. And I will send you the Grasshopper file. Wait a moment. Oh, those you got already with. You cannot delete any boxes. Yeah. Marie is saying that you just have to restart. Like, you know, everything what is going wrong. First of all, you should try to restart your computer. Yeah. Um, uh, the the code. Okay, I will just save it. I'll try to. So you have my my file in the chat box. So if you open the chat box on your Teams, I send it directly in your comments. You can take those files. Yeah, but if you want to take a coffee or drink something like me, it's the time now to do it. Okay, we are continuing. Last half hour, so before the lunch break. My question is, do you have these points now? Raise your hand if you have those points. Okay, anyway, I will continue to not stick with the recording. So I have the points which are at least from the offsetted lines. And now the operation which I want to explain, it's generally a very important one. So if you don't really have this specific points, get some random points or even use the points from the series and work on those points. I will use on those since I want to finish with the this part of the day with the floors. So I have a point. I am deconstructing a list of points. So again, I have something reversed from what I have been doing with the series. Here I was inputting the list of doubles, floats. Here I am exploding the point into a list of doubles. So I will go for the panel. And I see that generally I have the numbers. If I have the numbers, but they are without any order. So we have a tool here. So generally, if I would like to create a range, I would like to have the minimum in the X and the maximum in the X. So what I have to do, I have to sort those values. I will get then sort a list. If I have the sort list command, I can combine the X values to the keys and the outcome should be the list which is generally sorted. If it's sorted, then it's very easy to me to get a minimum and a maximum because as I was talking before, list item, the first one will be the smallest one, so 0, or I will maybe use panel, will give me the first one, and -1 will give me the last one. So now I have a minimum X coordinate and maximum X coordinate. What I have to do now, I have to do exactly the same, so I'm copying it for the Y component. So now I have generally the boundaries of my geometry. If I have a boundary of my geometry, then it's very easy for me to create a rectangle which is in this range. If I go for the rectangle, I have something like create a rectangle from a base plane and 2 points. I just need to create 2 points. And 2 points, it's the minimum X and minimum Y and maximum X and maximum Y. So if I will construct X, Y, Z, it's like I have to need 2 points. And here I have a minimum X and I need also minimum Y. I need maximum X and maximum Y. This should deliver to me a perfect rectangle which is reacting on the offset, and it's generally so again, sort list. Here you coming with the list into keys. Keys are sorted, and then you can sort, I am taking the first one and the last one. Here I am using -1 to find the last one, and here -1 to find the last one. So the most important thing is not to focus on the general where what to connect with what. It's generally to think what you really need to create a rectangle. Since I was looking for the boundary of my grid of points, or any kind of the points in the orthogonal system, then I need the minimum x and the minimum y, maximum x and maximum y. You have to remember that every geometry you can explode into simpler one. If you have a surface, you can explode it into the curves. If you have a curve, you can explode it into points, or at least starting ending points and the control points. So before you start doing such kind of the operations, think what you really want to do. Okay, you have a rectangle, and now the only thing which we need is since we have a rectangle, then I would like to create a surface. I will type surface, and this is doing exactly the same as boundary surface, but it's just a shortcut. So surface container, if he will find a flat curve, which is closed, he will automatically change it in the surface. And so maybe more classic way of doing it, it's using the boundary surface, which is a comment, but this is also what you could do. So don't be shocked if somebody is connecting a closed curve into surface container and he got a surface. It's working in two ways. If you have a surface, you could theoretically change it in the curve. But this is working very well only for untrimmed surface like rectangles and simple shapes. With more complicated shapes, it doesn't have to work so easily. So I recommend most of you to use boundary surface if you have elements. Okay, so we have boundary surface. The only thing which we have to do now to have a brep, we will be extrude. Or let's go into the surfaces freeform, and let's check what we have. We have extrude, extrude along, extrude point, extrude linear. We have, of course, loft, which we have been using before, but to not use it again, I will go for the extrude. I will use my surface, and the direction, it's the Z vector. So I'm typing just Z, and this is unit Z. This is nothing if is different than normal vector. So if you would like to create a vector XYZ, you just have to declare here 1, and you have your unit vector Z. So this is vector 001, and this is vector 001. No matter what you do, it will change it. Let's check if I will use a point XYZ construct point, which has got one here. If we will work, it is working the same. Generally, because vector and point is just an array of free floating numbers. So per definition, Grasshopper is able to change each point into the vector and vector to the point. But let's stick to the how it should be done per definition. We have a vector. We have a vector. This is a multiplication of 1. So I would like to have something between 0.1 to 0.5. And this will be the height of the slab. So I have my slab. This is closed brep. The only thing which I need to do now is to project it on the correct planes. I was having these planes here, so I'm just dragging it here. Plane XY, 5 of them. Project geometry, which is a B-rep, and the plane. If it's working correctly, closed B-rep, closed B-rep. Yeah, the projection. Why it didn't work here so good? Because we see that it's a flattened surface. Although it's writing it's a closed B-rep, it didn't manage to move it to the plane. Because projection, it's like getting all of the objects in, it's flattening it on the specified plane. So in this case, we cannot use projection. If we would be using surface, it would be possible, but in this case we have to use a little bit different thing, which will be move to plane. So I will go for the plane and geometry, and we should generally have our geometry made. Move to plane where it is, Control Shift, Shift Control plus Alt plus left mouse button. It's here. Transform, move to plane. I'm connecting planes and geometries, and I have my object. So I will have the move to plane geometry. I will call. I will make a B-rep. This will be my floors. I have them here. And I also need my so anytime I'm changing, it seems like the building or the model is reacting. Let's see this one. Yeah, it's also reacting. Here we have offsetting. Yeah. So I can generally create fully parametric model of the building. Now we have a B-reps, floors, and columns. We will work on them. I will send you this file again, because those of you who didn't catch how to do it, they can just take it from here. Let me upload. This is this one. So you have in the comment. Also, I will apply it to the Google Drive. So now, if you are using the link to the Google Drive, you will find in the bottom of the mural, and here you can go into the. You should have this day 2 part 1 Grasshopper file. Okay. Any questions? If no, Then I am continuing. We have BREP columns, BREP floors. I will just show you one trick. If I will Control-C, Control-V them, you can make something which is called internalized data. If I will internalize those data, it means that this is generally holding the same data as this one, but it's not anymore parametric connected. So it is in Grasshopper, not in Rhino. I cannot catch it here, but it is not connected to this code. So if I will make it smaller, this is this building, but this is the older version of it. So this is still parametric, like, or both of them can be parametric, but this is like you could call it baked internally in the Grasshopper. I will take this as a starting point, and I will turn off this code. So this code, let me check where it is. I move like this. This is a code needed to create floors. This is code needed to create columns. This is code needed to create grid of basic grid of our points. I think it's quite clean. Now we have BREP columns and BREP floors, and we will be working now only on those two. So BREP columns, BREP floors. Now I would like to, for the next 14 minutes, explain you a little bit how to make, how to use dispatch and how to categorize elements according to their properties. So let's go and take BREP columns, and for example, let's deconstruct it. Deconstruct BREP. So any kind of the geometry we can or not every. There are basic options which we cannot deconstruct. Like if we have a point, we can deconstruct it only into 3 numbers, and those 3 numbers we cannot deconstruct in something less. But BREP we can generally deconstruct. If I will take this BREP, we can deconstruct it in the faces, which very often are surfaces. We can deconstruct it in the edges and the vertices. So now each of this column has got a face and edge and vertex. So you can see that it's generally one long column. Now I would like to generally find those columns which are, for example, in some kind of the distance from the coordinate system. The internalized data, I suppose you are asking for. So I Control-Z, Control-V those one. Right click, internalize data. Right click on the container and then internalize data. Yeah. Whew. Okay, so at least somebody is following. Then we have a deconstruct BREP, edges, faces. Each of these objects have also properties. So if we go for the area, for example, we can measure an area of the face, but we can also find the central point of the area. And it's very useful tool and very also fast. It found, like you see, the points which are the central point of the vault, which is describing the shell over the pipe, the top and the bottom of each column. Now I would like to take all of those points, for example, and make, since this is just a classic point, so this is X, Y, Z point, I can now flatten it. So it is, or I will stay without flattening. Let's say we will not flatten it. But if I will go into it, I will see that in general, I have points which have almost the same x and y. Here we see some small issue. This should be 0, but it's almost 0. This is also quite interesting thing that it appears here. We will try to solve it. It's very nice that it is here, because very often we have some small issue with the precision of the drawing, and generally this should be 0, but let's take a look how the rounding it's dealing with this. Unfortunately, rounding it's to the specific number of digits. So I will tell you later in the C# how to deal with this issue. Anyway, I will what I will do now, I will generally flatten all of the faces, not the points, or maybe not even the faces. I will just flatten all the B reps. It didn't help to flatten the faces, so it is creating 3 points, but I will maybe flatten it even before to let you to see that it's react here. This is a flattened list of the B reps. We are deconstructing. For each of the B rep, here's creating 3 faces, bottom, top, and the shell over the pipe. And now we would like to project those points on the XY plane. Per default, it's XY plane. So if I would measure it now, I see that I have 0, 0, 0, 0, 0, 0, 0, 0. Here you have a small problem, but we will deal it in a second. And generally, I know where is the position of each of the column described by its basic point. So from the B rep, I figured out where is the basic point on the XY plane. Now I would like to delete those points which are generally duplicating. So I don't want to have 3 points which are very close or almost, or they are the same. I just want to have 1 point. I will use then clean, or sorry, delete duplicate cool duplicates. This is what I was looking for. So cool duplicates, Control Alt, it's in the vector cool duplicates. Vector point cool duplicate. Let's connect it here. And here we have something which I was looking for, which is generally a tolerance. Now, if I will grab it, you see that he generally take this point and create 1 point for all of them. He make an average of the x, so this number has changed. It generally didn't clean it because it should be here 0, but this we can solve in C# next hour. But for me, this is important that we can that we have the clean list of points. So now these points, sorry. Basic point of column. Okay, let it be. So this is a basic point of the column. It is a data tree. I will just flatten it. What is interesting that since I have 24 BREPs, I have also 24 points. So what I can do now is that I can take those points, make another container for the BREP columns, take it here to have it both. I will just make a print screen for those of you who are following. And we have basic points and BREPs. They are corresponding because we didn't move anywhere those BREPs. So the first point in this list, it's for the first BREP in this list. So if I will take a list item, turn off all the preview. This is the element and this is a point. What is the BREP representing? What is the BREP representing? Good question. Maybe I should explain it before, but BREP is generally the object with the volume, which have also a surface. So if we go into the Rhino, if you have a surface, this is also a BREP. So this is also a BREP, so something with the volume and the area. So if you have a geometry in the Rhino and Grasshopper and it has got a surface or area, sorry, an area or volume, this is a BREP. So it's yeah, boundary representation, yeah, BREP. You can understand it like this, that but yeah, the curve, it's not a BREP. It's everything what has got an area or volume will be a BREP. And it's kind of the general. You don't have something for a solid or extrusion as a container. Generally, if you go into params, here you will have all the geometry types which you can have. So you have a box, you have a BREP, you have mesh, which we didn't describe yet and did. We have a surface, and for the like the area volume representation, that's all. We have a basic geometries containers like point vector. Then we have curves, so circle, curve, plane. Plane, it's not a curve, but the line and circular arc. Rectangle, it's a curve. Plane, it should be, I think, in a point in vector. But anyway, you have also the geometry, which is can hold all of them. So if you are looking for the geometry which have a volume or area, this is a BREP. This BREP, in this case, it's again the column to make it clean. And now if you have from 0 to 5 the slider, if I will connect it here, then you can see that this is a BREP and corresponding to it a point. Now I would like to have a code which is when I am creating a rectangle, a curve, which is drawn in Rhino. So I draw a rectangle here, just like this. I take a curve, so I type curve, right click on it and set one curve. I am setting this curve, so it is taking it from this curve. I would like take all the columns which are inside this curve. I think doing it manually will be kind of the time demanding, so we'll try to find the solution in a better way. Since it should be a lunch break, we will do it, and I will continue it after the break for the next 15 minutes, and then we will start the C#. I will prepare the file for you, this one. You can generally take it from from the Google Drive. If you have any question, just leave it in the comments or just write me privately on the chat. So we are back at 12:30, and we will continue for 15 minutes with the Grasshopper and then C#. So be on time. I killed the workshop. Nobody's reacting to anything.
I don't even have soap, I think.